In the face-to-face session, we discussed that airlines typically use booking time to differentiate passengers. Those who show up early and purchase ticket early are more likely to be leisure customers and who are uh, price sensitive and are willing to pay low price. And those who show up in the last minute are more likely to be business customers who are less price sensitive and are willing to pay a much higher price. That's why typically you see in airline industry, when you book tickets early, the price is low, but if you wait until last minute, the price will go up. Now the question is, how many seats you want to reserve for those who show up in the last minute? What makes it difficult is we don't know how many people will show up in the last minute. So if you reserve too many tickets for last minute passengers, you may end up not being able to sell all the tickets. If you don't reserve enough, then you lose potential revenue. So in this session, we're going to discuss a model to determine the optimal number of seats to reserve for last minute passengers. We call a protection level. So what is the optimal protection level? So we are going to cover one model. It's called critical fractal model to determine the optimal protection level for airlines. So for this model, it involves 4 different steps. For step 1, to identify the following information. So you read the question, you identify the following information. The first piece of information we need is discount price. So what is discount price? The second piece of information is the full price. What is full price? So for example, for a particular flight, the discount price can be $100, but if you wait until last minute, the full price can be $500. So this is discount price and full price. We also need to know what demand looks like for full price market. So how many people are likely to show up in the last minute? So we're talking about full price demand information. So not discount price demand information, we'll look at full price demand information. We want to know how many people will show up in the last minute. So for the distribution, we need to know the mean, which is mu, and the standard deviation as well. So we need to know 2 numbers, mu and sigma, the mean and standard deviation. So that is step 1. So read the question, identify the following information. Step 2 is calculate the critical fractal. So this should be pretty straightforward. So this is a formula, which will be F. F is full price minus D. D is discount price, and then divided by F. Step 3, first of all, so given the critical fractal calculated in step 2, we calculate P. So P is equal to critical fractal minus 0.5. So remember, it's always minus 0.5. Okay, it's always minus 0.5. Then we take the absolute value of P. So which is, this means look at 2 vertical bars, 2 bars here. This basically means that the absolute value of P. So use the absolute value of P to search for the Z value from where? From appendix A. So in the exam and all the practice questions, appendix A will be provided. So use the absolute value P to search for the Z value. The next slide, I want to show one example how to do this. So you can see if P value, if the P is positive, then it's pretty simple. If P is negative, we have to take absolute value, make it positive first before we search for the Z value. So when you search for the Z value, sometimes you may not see exactly the same value in the table as P. Then in this case, we choose a close number. The last step, we have to adjust the sign of the resulting Z value accordingly, such that P and Z have the same sign. So if P is positive, then we make Z positive. If P is negative, we make Z negative as well. So basically it means P and Z, they have to have the same sign. So last step, step 4 is to calculate the protection level. So which is just one formula. So protection level is equal to X. X equal to mu. Mu is the mean demand for the full price demand. Plus Z. Z is the Z value from step 3. And sigma standard deviation full price demand. So these are the 4 different steps. Let's look at a particular problem. So I have a airline. This particular airline used Boeing 737 for its route from Los Angeles to Las Vegas. The capacity is 95, full price is 69, discount price is $49. The estimated full fare demand follow normal distribution with mean 60, standard deviation 15. So mean 60 means mu is equal to 60. Standard deviation 15 means sigma is equal to 15. Question: how many seats shall we reserve for full fare passengers? So what is the optimal protection level? So let's follow 4 steps to determine the optimal protection level. Step 1, identify the following information. First of all, we need to know what is the discount price. So if you look at the question, discount price is $49. The second piece of information, what is full price? So full price F equal to 69, also from the question. Then we need to know what the demand looks like for full price market. So full price demand distribution. So full fare demand distribution, average or mean is 60, standard deviation is 15. So that means mu is 60, standard deviation sigma is equal to 15. So these 4 numbers are all the 4 numbers we want. So this is step 1. Pretty straightforward. Just read the question, identify these 4 numbers. Step 2, calculate critical factor. So use a given formula. So F minus D and then divide by F. So F is 69, D is 49. You do the math, you'll get 0.29. Step 3, we need to calculate what is P. So how is P defined? So P is defined as critical factor minus 0.5. As I said, it's always minus 0.5. That's the definition. So P is equal to critical factor as calculated in step 2 minus 0.5. So what is the critical factor in this problem? So which is 0.29, 0.29 minus 0.5, we get negative 0.21. Okay, negative 0.21. So now we have the p-value. Now once we have the p-value, we are going to search for z-value. So as I mentioned, you cannot use a negative p-value to search for z-value. We have to take the absolute value for p. So we take the absolute value of p, which is just simply getting rid of the negative sign. So we have 0.21. Okay, 0.21. So we use 0.21 to search for the z-value. What do we search for it? We use Appendix A. Appendix A. So next slide, I'll show Appendix A. So search Appendix A according to the absolute value of P, which is 0.21, and we will get a z-value of 0.55. So z-value is 0.55 based on the p-value. So last step, as I said, we make sure P and Z have the same sign. So here, P is negative, so we don't use 0.55, we have to add a negative sign back on. So because P is negative, we want to make sure Z is negative as well. So Z is not 0.55, Z is a negative 0.55. So make sure P and Z have the same sign. So if P is positive, then Z is positive. If P is negative, then Z is negative. So once we have the Z value, we can calculate the protection level. X equal to mu plus Z times sigma. So mu is a mean demand. Sigma is standard deviation. Z is Z value from step 3. So we plug in all the numbers, we get 51.75. We round it up to 52. So we should protect 52 seats for full fare demand. In this case, we round it up. Okay, so it's 0.5 or above, we round it up. If it's 0.4 or below, we round it down. So this is the one example how to practice, how to determine the optimal protection level. So step 1, step 2, step 4 are pretty straightforward. Step 3 can be a little bit tricky. One thing you need to keep that in mind is P and Z, these two values, they will have the same sign, both negative or both positive. So this is Appendix A. You go back, look at here. The absolute value of P is 0.21. So based on the absolute value of P, which is 0.21, how do we get the Z value of 0.55? How do we get it? Look at this appendix. So in the middle of the table, look at all these numbers. The numbers with 4 digits, okay, 4-digit numbers. These are the p-value. These are the p-value. We search for what? 0.21. We look, which one is 0.21? You probably don't see the exact number of 0.21. In this case, we look for the close number. So which one is the close number to 0.21? So this one, you will see this one is the close one. Okay, this one is the close one. Close the number to 0.21. This is the p-value. So based on the p-value, we can find out what is a corresponding z-value. So you draw a line, horizontal line, and then you draw a vertical line. You will see the z-value is 0.5 and z-value is 0.05. We add them together. So 0.5 plus 0.05, the z-value is 0.55. Of course, in the end, we're going to add a negative sign back because we want to make sure p-value, z-value have same sign. So this is how to use the Appendix A to identify the z-value. Now let's look at one more practice question. Here, talk about hotel. A ski resort is planning a year-round promotion. The normal rate is $299, special rate is $159. So estimate full rate demand follow normal distribution with mean 50 and a standard deviation of 10. So how many seats should be reserved for full rate guests? Or how many rooms actually? How many rooms should be reserved for full rate guests? So step 1, identify the following information. So what is discount price? Discount price $159. What is full price? Full price $299. We also need to know what is the demand for the full price market. So full price demand distribution, mean is 50 and mu is 50. Standard deviation is 10, sigma is 10. So that's step 1. Step 2, calculate the critical fractile. So using the given formula, so F minus D divided by F. So we plug it in the value for F and D, 299, 159, we got 0.4682. Step 3, we want to calculate the z-value. So first of all, we calculate what is p-value. So as I mentioned, p is defined as critical fractile minus 0.5. So which is 0.4682 minus 0.5, we get negative 0.0318. Because p is negative, we have to take the absolute value. So we take the absolute value of p. So just simply get rid of negative sign. So we will have 0.0318. So that is the absolute value for p. Then based on this number, we search for the z-value. So we search for z-value according to the p-value, which is 0.0318. You go to Appendix A, you will see the z-value will be 0.08. So this is z-value. But that's not the end of story. As I said, you have to make sure both p and z will have same sign. In this example, because p, look at p is negative. The original value for p is negative, so we have to make sure that z is negative as well. So here we obtain the value for z, which is 0.08. This is not the actual z value. We have to add the negative sign back. So as p is negative, we make z negative as well. So the actual value for z is negative 0.08. So once we have the z value, we do the last step, step 4. Step 4, we calculate the protection level. So protection level. So protection level is simply x equal to mu plus Z times sigma. So 50 minus 0.08 times 10, you get 49.2. So we round it down. As I said, if it's 0.5 or above, we round it up. If it's 0.4 or less, we round it down. So it's 49. So we should reserve 49 rooms for the full fare guests